Number 1. The discrete random variable x has the following probability distribution function. Okay, so you got 4 points, 2, 4, 7, 10 with respective probabilities. And quick note, all probabilities here must always add up to 1. Okay, and for any other x value, for example 3 or 5, etc., the probability value is 0 because they've all been defined. So that's an important rule to take in. Now the cumulative distribution function of x is fx. Cumulative means that you add the probabilities as you go along. For example, if they told you to find the function at 4, this means you add all the known probabilities up to 0.4, so a plus b. If it's somewhere in between like 3, remember that 3 here would fill under other, which is 0. So the only value you would have is 2 and 3, which means a plus 0, so it would just be a, and so on. Okay, so we know that f3 here is 0.2 and f6 is 0.8. So f3 means up until 3, so it would just mean a only. So the probability of a is equal to 0.2, so we can call that this value is 0.2. And f6 equals 0.8, so probability is up until 6, so that includes 2 and 4 only, because the value 6 would be 0, so it would be a plus b is 0.8, so that means it must be 0.6, because these two must make 0.8. Now, yep, so a is done, so write down the value of f7. f7 just means you add along, so it would just be a plus b plus 0.1, which will equal to 0.9. And of course, c must be 0.1 because adding all these probabilities will give us 1. Okay, number 2. So for this question, I've actually solved it all in advance, only because there would be a lot of, calculation there, and it's better to get to the point of this. So let's have a quick read, yeah? So the following group frequency distribution summarizes the number of minutes to the nearest minute, okay? When you see this word nearest minute or nearest something, what they're trying to tell you is that if you look at this section here, you'll realize that there's gaps after every interval, like between 6 and 7 there's nothing. That's because it's been rounded up, rounded down or up. And what we really need is the non-rounded values. So we have to 0.5 plus minus 0.5 on each side to get what it could have been before you rounded it. Okay, and that's it. So moving on, it tells that they have a random sample of 100, which were delayed by roadworks on a stretch of motorway, and so on. Okay, so that's fine. So n is 100. So this means all of this, all the total frequency, which is f, adds up to 100. Okay. Next, they give us the midpoint values here, which are between each of these ranges. So that's great. We're going to use this to find fx later on. Now, let's keep going. So a histogram has been drawn to represent this data. Now a histogram looks a bit like this, yeah? This is just a general formula. The way I look at this is that the frequency here, which is the number motorists, must equal the class width times some height, known as the frequency density. Now we're given the class width over here, which I found, which are the non-rounded values. And to find the actual width of it, it would be the difference. So these values in brackets are the values of the class width. Let's just call it width, yeah? And to get the frequency density, it would just be base times height equals area. So since we know for the first one, for example, the width is 4 and the height we don't know, but we know that the area is 38. So we can say, okay, to get the height, it would just be 38 over 4, which will give us 9.5. And then you do the same for the rest. So 25 divided by 2 is 12.5, and so on. So you should get your frequency density. Now, we're going to use this for part A, yeah? So the bar representing a delay of 3 to 6 minutes, so over here, has a width of 2. So this means that we know that the number of minutes of the width is 4, but it's measured in centimeters, so 2 centimeters equals 4, which I put over here. And has a height of 9.5, which is the frequency density. So in units, in centimeters is 9.5. Equivalently is also 9.5 units. So these two are the same. And they want us to calculate the width and the height of the bar representing 11 to 15. So they want us to actually work out in centimeters the width representing this and the height of that. Now, looking at the 3 to 6 one, if every 2 centimeters equals 4 minutes, that means for 1 minute, just dividing by 4, you get 0.5. So it's good to kind of think of these as ratios. And for the height, it's basically 1 to 1, because 9.5 centimeters equals 9.5 units. Now for 11 to 15, the delay group, we can see that the class width is 5 minutes. And we know that for every minute, it's 0.5 centimeters. So for 5 minutes, if you times it by 5, you get 2.5 centimeters. And then for the height, the frequency density, for the 11 to 5 group, we got 2.4. So, and thankfully, because it's 1 to 1, 2.4 units must equal 2.4 centimeters. And that's it. That's literally done. Now, let's go to the next one. Okay, so use linear interpolation to estimate the median delay. Okay, so I always update these slides, by the way, guys, just so with new information. Now, to get the median delay and to use interpolation, you got to use some kind of method like this. So I started over here. And the keyword is median. Median means the middle person or the middle motorist. Because we've got 100, this means that the middle person must have been the 50th, or technically the 50.5. But you can say 50th is okay. Now, the trick is to firstly, separate this into two groups. Ignore these values for a second. So this is going to be the 50th person, and this is going to be the nth minute, representing 50. So looking at our table, we just need to find the cumulative frequency up until that includes the 50th person between. So basically, find the cumulative frequency from here all the way up to 100, and you realize that the 50th person must lie between these two values. So then we plug in, so then we write 38 here and 63 there, because 50 lies between. That means the minutes that lie between must be equivalently between everyone up to the 6.5 minute and everyone up to the 8.5 minute. Because remember, this includes everybody up to all 63 people included so far. So that means the highest it could have been is 8.5. And same for this one. For 38, this means everyone up to 38 motorists, meaning the highest delayed minute could have been 6.5. So that's why you have to make it corresponding. So that's the easy bit. The next bit is to literally form an equation. Now my trick is to literally just look at this and just find common ratios. So I'll say, all right, hang on. So between the median 8.5, the difference between these two must be equivalent to the difference between 50 and 63. So that's why I put them over like a ratio. Then I pick another comparison. I chose, just to make it easier, the difference between 6.5 and 8.5 is equivalent to the difference between 38 and 63. And that's why I made a ratio like that. And all you do now is just evaluate this and make m the subject. So the quick way to do this is to smash this right hand side into the calculator and then multiply it by 50 minus 63, which is minus 13, and then finally add 8.5. And then you should get m equals this, 7.46 minutes. If you guys get a different answer, and if you use 50.5, you would actually get m equals 7.5 minutes. Okay, it depends. I mean, it's not really a big deal. It's probably more accurate to say this anyway, but 50th should be fine as well. Anyway, let's move on to C. All right, mean and standard deviation. So these ones, they're not so bad. They're very quick. Now, for this one, as just like the previous questions, you'll need to make a brand new column, yeah? You need to firstly have an fx, because this is needed for the mean and standard mean formula in particular. So let's have a look. So fx just literally means frequency times x, so that's why I put little x signs. So 38 times 4.5 gives us 171, and doing the rest, multiplying the rest of these, you should get these values. And then you'd have to sum these up, okay? So you can have the sum of fx, and it should give us 811.5. Now remember, they also gave us this. I mean, if they didn't give us this, then you would have to find another table called x squared and square each of these values and then sum them up. So trust me, that would have been long. So this is actually convenient. Now using the mean formula is easy. It's just the sum of fx over n. And we know that the number of motorists was 100 because these add up to 100. So just sum of fx, so 811.5 over 100, and that'll give us the mean. So it should be around this. But yeah, guys, let me know if you guys get something similar, yeah? Now for D, to find the standard deviation, it's always easier to find the variance first, because the variance is the square of standard deviation, and it looks easier formula-wise, yeah? So the good thing is, it has the same relationship. Instead of the sum of fx, it'll be the sum of fx squared. So we're going to use this value here, okay? Over the sample size. So that's why you got this over 100. And then we have to minus that by the mean squared. And that's it. You put all this in a calculator, square root answer to get the standard deviation, and you should get 3.887. That's it. All done, guys. Again, compare with me and let me know if you guys got something similar. And let's move on to the last two. Okay, so I've copied out the mean, median, and standard deviation values because this is going to be needed for this formula here. Okay, now let's have a read. So one coefficient of skewness is given by the 3 times mean minus median. Another way they could have wrote this, by the way, is mean minus mode over standard deviation. So they could also ask you that. So this is not important anyway. Now evaluate this coefficient for the above data for what we're given. Give your answers to 2 significant figures. So just do what they say then. So the skewness, I use the gamma notation, you don't have to. Plug in the values into this formula and you should get 0.51. 2 significant figures. Next question. On the following Friday, the coefficient skewness for the delays on the stretch of motorway was minus 0.22. So there's a difference. Remember, this is talking about the original value. The original information was about Monday, because if you remember, going back to the beginning, it says on the stretch of motorway 1 Monday. So this data is reference to Monday. Okay, so that's our positive skewness, and for Friday it was negative skewness. Now F, state given a reason how the delays on the stretch of motorway on Friday are different. So one thing we can do is firstly try and draw a sketch. We can say that due to the difference of the mean, if the mean is less than the median, this gives us a negative skew, hence the answer. So this means that the bulk of the information is on the left tail. The bulk of information is on the right hand side with a long left tail. Whereas for Monday it's a positive skew, so we have a long right tail with the bulk of the data on the left hand side. And what this means is, if you look at the data set just to get information, you can see that most of the information came from the early minutes. So you can say most of the, what's this about? Most of the delay came in the early parts, because look how big the values are. Whereas on Friday, most of the delay came from the later parts. So that's really it. So you can add that information in, it's good. I kept it brief in my information, but always talk about the table values. And just realize that the tail of the distribution tells you where most of the data points are. And that's it, guys. I hope this video helped. Let me know if you got any questions for number 2. Otherwise, I shall see you guys in number 3. Ciao. Okay, number 3. So the random variable y has a normal distribution of mean mu and standard deviation sigma. Okay. Now the probability that y is bigger than 17 is 0.4. So that is the line over here, and the area bigger than 17 is 0.4. Okay. Just note that the left hand side is 0.5, and this little gap between the mean and 17 must be 0.1. The one thing to know about normal distributions is that it's always symmetrical about the mean. Okay. So this is something we just need to know off the bat. And this will be helpful for solving every problem. Now, A, find the probability that y is between the mean and 17. So that's literally this small region here, which is 0.1. So we've already solved this one. And you can see it over here. Now B, find the probability that y is between mu minus sigma and 17. Now to plot this carefully, we know what 17 is because we showed it in the beginning. 17 is on the right hand side, but mu minus sigma, because it's the mean take away some variable, it's going to be less than the mean, of course. So it has to be here. So this means we're really interested in the yellow shade region between that range. Now if we have to label every area, which is helpful by the way, we know that this part is 0.4, this part is 0.1. So we know part of the area. The only thing we need to work out is the area of A. But to do it, to make it more easy, it's easier to work out the area of B, because it's only less than. You're not finding between areas. So here, let's work with B. So to do this, you go find the probability that y is less than mu minus sigma. And then, of course, transform it to the z form, where you have to firstly do the variable minus the mean over sigma. And then when you get here, you can probably realize that we can actually simplify, because you've got mu take away mu, which is cancels out. And then you're left with minus sigma over sigma, which again cancels out, and you're left with minus 1. Now that's the easy bit. From here you can realize that you, on the normal distribution table, so let me just quickly flick over to it, you're only given table values with z values are all positive. You see that? So from 0, and this is just a snippet of it, we cannot have negative z values. So a trick I always do is to always take out the minus sign and do 1 minus. So to do this is always 1 minus the symmetrical bit. And then you can look in the table for 1. So now going back in the table, we can see that when the probability of z less than 1, so this is again the form they want, it should always be the less than form. If z is little z is 1, which I did here, we look at the table for 1, and 1 is over there. And then that's equivalent to a probability value of 0.8413. So this phi z is actually a notation for probability of the random variable being less than z. So this is a cumulative distribution. That's why the values are increasing. So let's go back to the question. So we know that this is 0.8413. So 1 minus this will give us 0.1587. That is the region of B. And therefore A is easy because A plus B must equal half. So then just subtract 0.5 from B, you're going to get A, which is 0.3413. And then to answer the question, we want the yellow region. So that's when you add up 0.1 and A. And that should finally give us 0.4413. And that's it, guys. All done. Okay, number 4. So a bag contains 64 colored beads. And in that bag, there are R red beads, Y yellow beads, and 1 green bead. Okay, so in total, if we add all these up, we should get 64, which they've done. Now, 2 beads are selected at random, 1 at a time without replacement. So keyword is without replacement, which means that if the first pick was out of 64, then if you chose another bead from the bag, you don't replace it, so you'll be left with 63, which you'll see in a minute. So find the probability that the green bead is one of the beads selected. Now this is easy. Just pick all the combinations where green is selected. So for example, the first pick could have been green, then I could have picked a red for the second. Or the first pick could have been green and then pick a yellow. Or in this case, the first pick could have been red or yellow, then green. So you can see that we've got 4 combinations. And once you do this, you literally just assign probabilities. So the probability taking a green the first time would be 1 out of 64, because that's how many there is. And on the second pick, we know it's out of 63. The red would be red R out of 63, because we still got all the red beads. And then for the green and yellow, same thing. Picking the green first is 1 out of 64. And then picking yellow next, we got Y yellow beads remaining, because we haven't touched it. It'll be Y out of 63. And then you just repeat the rest for RG and YG. Now, to answer this question properly, it's always the total. So you just have to literally work these out, multiply them, this is easy. R times 1, Y times 1, and then just sum all these up. And when you sum these up, you should get 2R plus 2Y out of 4032. And you can simplify this, which is just R plus Y out of 2016. Easy. Now, next question. Alright, so the probability that both of the B's are red is 5 out of 84. Show that R satisfies this equation, which is a quadratic. Now, going back to the statement here, the probability that both of the B's are red, this means that we need to show that the first time we pick a red, which is R out of 64, times the second time we pick a red, so we got 1 less red, by the way. So whether we had R minus 1 out of 63, multiplying these two should give us 5 out of 84. Now, the aim is to literally work with this equation here, simplify it, multiply out like I did below, and then just get this equation. So when you do that, times 4032 across, all of this times 432 gives us 240, rearrange it and you've got your quadratic equation. Simple, like not much to be said here. Now next one, C, hence show that the only possible value of R is 16. Now this is from B, so you look at the quadratic equation and you just have to solve it. I just use a quadratic formula because it's easy to use. Where you just have to recall, this is how the formula looks like. A, B, and C are the coefficients of the quadratic. So in this case, the coefficient R squared is 1, so A is 1, of B is minus 1, and of C is minus 240. So just plug into the formula like here, and doing it carefully, you should get R equals 16, which is true, we got that, we done it, we showed it, or R equals minus 15. And this is of course wrong because remember, you're working on the number of B's. You can't have negative amount of B's because that doesn't exist. Okay, so that's clear. Now D, given that at least one of the B's is red, so when they use the word given that, guys, yeah, remember that goes on the bottom, and that's always the total area, so we're only concerned about the given that region. Then find the probability that they are both red. So I just call this is for part D, so you go find the probability that you want to get red from the area which is at least one red. And now we just got to think about how to get at least one red. At least one red pretty much can be made of probability of getting red both times. The first one could have been red and the second one should have been not red, or you could have not got red the first time but eventually got red the second time. So these are the 3 options you could have got. And of course, getting at least one red means it could be any of these 3, so we have to add them up. Now to get red, we already have the answer, 5/84, because we got that in part B. And to get red and not red, and oh yeah, forgot to mention one thing. Because we know R is 16, we can literally solve the rest. That means you got 16 red, you have 1 green, therefore you have 47 yellow. So remember, this came from the original equation. That's going to be useful. So going back to this, so getting red and not red. So to get red first time, we got 16 out of 64 balls. And to get not red, it means getting green or yellow, which is add them up, 48 out of 63 left. And then the same thing, not red and red, you have 48, not red and 48, which are green and yellows, and so on. Same thing, pretty much identical to the second part. And all you want to do is solve these and then add them up to get a total probability of 37/84, which is the at least one red. And then finally, just smash in everything to the formula. Red, which is 5/84, at least one red, which is the total here. Put this in the calculator and you've done it. 5 out of 37, guys. Okay, number 5. So the score when a spin is spun is given by the discrete random variable x with the following probabilities. Alright, so it looks like we've got 5 points here, and the probabilities are unknown, where you got B, 3 A's and another B. Now the first thing you should always do for these kind of questions is always form an equation, yeah? So I said that the sum of all of these probabilities always adds up to 1, okay? And when you do that, you can do something on the right, like I did here. So if you add them all up, you should get 3A plus 2B equal to 1. So let's look at A and B now, questions. So explain why the expected value of x is 2. So why is the mean 2? Well, one way to explain it is that, without using math formulas by the way guys, is that if you look at these, the way the probability is laid out, it looks like it's a pattern. You got B's on the endpoints and you got 3 A's in the middle. This is actually symmetrical. If you think of this as a symmetry, bang in the middle is symmetrical on the left and the right. So that's one way to look at it. If the mean is symmetrical, then the mean is definitely the middle. So the mean will be 2 due to symmetry. Now, if you do it mathematically, firstly, let's go ahead and find what EX actually is. So first thing, so expected value literally means X times probability. So it's going to be, in this case, minus 1 times B, which is minus B. 0 times A is nothing. 2 times A is 2A, and so on. And then you get something like this. So when you collect like terms here, you should get 6A plus 4B. Factorize the 2 out and you get 3A plus 2B inside. Now this is quite important because if you think about it, when we collected probabilities, and if you did this already, you'll see that 3A plus 2B is equal to 1. So that means we've got 2 times 1, which is 2. So that's 2 ways. Now let's go to the next bit. So B is actually done already. So next one, C and D. So given that the variance of x 7.1, so straight off the bat, write a variance equation like I did here, which is equal to expected value of x squared minus the mean squared. And x squared literally means that you write an x squared here and make a new table. Okay, so here, so find the second equation in A and B, and simplify your answer, and then solve both equations from part B and C. Okay, so let's do this. So let's find out what EX squared is first, so that way we can go ahead and solve this. So EX squared literally means square each of these variables and then times against the probability. So let's have a look. So minus 1 squared is plus 1. So 1 times B is B. 0 squared is 0, so that's nothing. 2 squared is 4, so 4A. 4 squared is 16, 16A, and so on, 25B. And then collect like terms here, and you should get 20A plus 26B. So that's the value of EX squared. Now, if we look at this formula again, we have the value of variance of x, which is 7.1. So I'll put it over here. So variance x 7.1, EX squared, we just got it. Oops, and this is meant to be the mean squared, by the way. Little typo there. So the square should be outside. And this value here should be 4 because we know the mean is 2, so it'll be 2 squared, which is 4. And then they want you to simplify. So what I do is just plus 4 across, so you get 11.1 and make it equal to the equation. Now, to solve this, you'll notice that you have 2 equations. You got this one here, and you got the probability equation we did earlier on, which is equal to 1. So I just line them up like you do in a linear way, and then choose your method, substitution or elimination. For me, because it's linear equations, it's just easier to eliminate. So I literally just multiplied the probability equation by 13, so then the b's match up, so you get 26b. That means if you multiply the rest by 13, you get 39a from 3 and 13 from 1. And then you can just subtract the first and last equation to get 19a equals 1.1. Divide by 19 to get 0.1, and then plug in 0.1 to any of these equations for A to solve for B, which will give you 0.35. And that's it. So let's move on to the next set, guys. Okay, here we go. So yeah, just quick tip. So I've copied out the previous table and you'll see that I've added a few more things, but we're going to go through it. So let's have a look. So the discrete random variable y equals 10 minus 3x. So what this means is that you use the x values from your table, plug into the y equation here, plug into this formula here to get an expression for y. For example, if you plug in x equals minus 1, you got 10 minus 3 times minus 1, which will give us 13. And I just did the rest for the same. This is gonna be helpful for part F in particular, and maybe E, but not really. So E, find the expected value of y and the variance of y. So EY literally means that you just take expected value on the whole equation, so 10 minus 3x, and using the properties, if you take the expected value 10 of constant, it's just the constant is 10. If you take E on 3x, well, you only focus on the x, so everything else goes outside. So you're left with 10 minus 3 times the expected value of x. And EX, we already know, is 2 from part A. So that means it'll be 10 minus 3 times 2, which is 4. So that's done. Now the variance is similar, but things disappear. So you take the variance on y, so wrap it around the whole 10 minus 3x. The variance of a constant is 0, by the way. So because variance means the spread, and there's no spread around a fixed number. So that's 0. And then the variance of minus 3x, well, you always square the constant. So you got square minus 3 to get 9. And then the variance x, we already know, it was given in over here at 7.1. So you're left with 9 times 7.1, which is here, 63.9. You guys can double check my answers, by the way. I haven't really verified them. And now finally for F, which is here, and it says the spin is spun once. So this means we're looking for a single probability option, yeah? Find the probability when y is greater than x. Now this is related to what we did here. So you see this table here, we literally just see when y is bigger than x. Well, we can see it's bigger on when we can see that 13 is bigger than minus 1, 10 is bigger than 0, and 4 is bigger than 2. So it occurs 3 times, and these probabilities are equal to these 3 here. So 35, 0.1, and 0.1. And that's it. You just add them up and you get 0.55. Yeah, and that's it, guys. That's literally number 5 done. Alright, number 6, guys. So just like question 2 and a few other problems, some of these questions are actually really lengthy to solve, especially on a calculator. So I've pretty much summarized everything in a neat way, which can help you show you the steps you should take to solve every problem. So let's have a look at number 6. So a group of climbers collected information about the height above sea levels, h meters, and the air temperature T degrees Celsius at the same time at 8 different points on the same mountain. So it said 8 different points, so straight away the n value here, the sample size is 8. Okay, now the data are summarized below. So the sum of the heights was this, the sum of the temperature was that, and then you got the sum of TH and T squared. They also want us in part A to show that that STH and STT are given as shown. Now this is just straight up simple formulas. You should be familiar with the SXY and SXX or SYY formulas. It's just the sum of the variables TH minus the sum of each one, T, and the sum of H over the sample size. In this case, the different points. So just plug in the values you see. Sum of TH is given here. Sum of T is 61 and sum of H is 6,370. Just smash in the calculator as you see fit and you should get the same results. Same with STT, you get the same results. And yeah, for STT, you're going to use ST squared because imagine this as TT. For the top here, it will be the sum of T times the sum of T or the sum of T all squared, but do it like this so you don't confuse the two notations over N as well. And again, same result. Now, let's move on to the next bit. So the product moment correlation coefficient, so this is the R value in the S1 notation, for these data is minus 0.985, so it's practically close to -1, almost perfectly negative correlated. State given a reason whether or not this value supports the use of a regression equation to predict the air temperature at different heights. So the answer would immediately be yes, only because when you use a regression equation, it measures how close the data points fit on a straight line. And because if you get either +1 or -1 regression, what that tells you is that the data is either perfectly positively or negatively correlated. So you want to be on that line. So you want to be as close as possible to plus or negative 1. So yes. And my reasoning here is that r is close to negative 1, which indicates an almost perfectly negative linear correlation between the temperature variable, the air temperature, and the height above sea level. So yes. So yeah, as long as it's very clear that you stay as close to 1, plus minus 1, then you're fine. So let's go into C, guys. All right, part C. Find the equation of the regression line of t on h, giving your answer in the form t equals a plus bh. And here we have to get the value of your coefficients with 3 significant figures. Now these coefficients are your a and b, so that's what we need to find. And this is easy. To find the value of a, you just have to literally rearrange this regression line to make a the subject, and then flip this a and h with bars. And just to know what the bars are again, the t bar, for example, means the sample mean of t. So it's the sum of t over the sample size, which is 8. And the same thing for h. H bar is just the sum of h over 8 as well. Now, to work out b, and this is the part where you're literally going to be thinking about this for a while, is it going to be SHH or STT? Well, one little tip. This question is worth 7 marks, so it definitely can't be STT, or else you would have solved this question in literally like a minute or so. Secondly, the reason why it's SHH is because it's always, if you worked with x and y, it's always b would always equal sxy over sxx. And in this case, looking at the equation, the y variable is t and the x variable is h. Hence why it has to be SHH to make up the marks. Now to work out SHH, the only way to possibly do it is to relate the R value, the correlation value, with all 3 S values. Since you're given already 2 of them, and you're also given R value, which is over here, so that's actually useful. You just have to make SHH the subject. So what I did, I just moved it around until I made it look a bit like this. Okay, just simple rearranging. And then just plug in every single value carefully in calculator all at once to get a result something like this. So about 1.3 million. So if you guys get something similar, let me know. I'll try and post your values here because I'm doing this all repeatedly just to make sure the values are correct. Okay, and I've been using sources online like student forums, so thanks to you guys over there. So yeah, always share your results and let the community know. Now once you find SHH, plug it back into the formula for B, which is here, and of course STH, which is also given, to get this answer, the B value, and round it to 3 significant figures. So you should get something like minus 0.0126. And then using that B value, plug into the A equation and use T bar, which I've already given here, and H bar, plug it all at once, and you should get an A value of 17.7. And that's it. That's literally all you have to do for C. And it's worth a lot of marks. So this is something that you want to make sure you're bagging, especially. And if you're not sure, sometimes even under exam pressure, you might think STT. If you did do it, you would realize that you'll get kind of a ridiculous answer. So that alone can help you think about which is the best choice. But anyway, let's move on to D. So D. So give an interpretation of your value of A. So A is the 17.7. So looking back here, this is the A. So what that really tells us, and I put over here, that A represents the initial air temperature and of 17.7 degrees Celsius at sea level. So i.e. when 0 meters above sea level. So what that means is that you got to assume that H is 0. So this is literally the intercept on a graph. If you picture it like this, you're going to see that 17.7 is a y-intercept, and it has a negative gradient, so it's decreasing over time. So this means that initially it has a temperature of 17.7, but as you go above sea level, the temperature slowly decreases to a certain point. So that's what it's trying to say. Now E. Oh yeah, so one of the climbers has just stopped for a short break before climbing the next 150 meters. Okay. Estimate the drop in temperature over this 150 meter climb. So this wants you to find the change in temperature. So all you literally do is firstly put the value of 150 into the calculator and then see what that gives you. So T equals 17.7 minus that variable times H, and you should get 15.81. So this is the new time. So you can see it's dropped to somewhere around here, 15.81 degrees. All they want to calculate is the change, the drop. So the drop is just the original temperature at 17.7 and 15.81, and that should give you a drop of roughly 1.89 degrees or 1.9 degrees Celsius. And that's all right. Number 7. So farmer Adam grows potatoes. The weights of potatoes in grams grown by Adam are normally distributed with a mean of 140 and a standard deviation of 40. Now, always write this formally, yeah? So I'm going to let W be the weight of potatoes. So this is the random variable, and it's going to be normally distributed with a mean of 140 and variance 40 squared, or standard deviation 40. Okay, so key things to note here, yeah? Now, next part is important. Adam cannot sell potatoes with a weight of less than 92 grams. Okay, so this is vital. Now, always try and draw this out. So illustrate with a bell curve. Put the mean of 140 bang in the middle. So this has to be symmetrical. And put 92 on the left. Because remember, this is all in ascending order. So we know, so this is the area that is less than 92 where Adam cannot sell his potatoes. Okay. So let's see the question A. So find the percentage of potatoes that Adam grows but cannot sell. So indirectly, this is the probability that of being less than 92, of a weight less than 92. So we write down, find the probability of W less than 92. And now the next step, you just have to be comfortable with normal distribution. We always have to convert the random variable to the Z standard normal, which is the value minus the mean, which is 140, over standard deviation. So let's look at the steps. And then you just put this in a calculator, you get minus 1.2. And now remember that the standard normal table, so I got a little extract here, they're always positive values. So you kind of have to whip out this minus sign out and write 1 minus the same thing. So that's a technique, guys. You can always write probability Z is less than something, which is the same as, or minus X, which is the same as 1 minus the same thing, but of just X. So this is a nice little technique. So anyway, you do that, you got 1.2, look at the normal table, 1.2 is here, and you get 0.8849. So 1 minus this value is 11.51%. Okay, part B. So the upper quarter of the weight of potatoes sold by Adam is Q3. Now we need to find the probability that this weight of any potato grown by Adam is more than Q3. Okay, these kind of questions, always, and for literally every question in the normal distribution, always redraw the bell curve with updated information. So we know that from part A, the unsold was 11.51%, which is less than 92. Now they want us to find Q3 of the sold, which is of the white region. So we need to basically take 3/4 of the area of the white region. And the area of the white region is 0.8849. That's 1 minus the unsold. So that'll give us this probability here. So 3/4 of 0.8849. And now the reason why I added the unsold region is because if you don't do that, you're going to end up having a wonky, the Q's in the wrong place. So this will cause a shift to the right. So if you add this, it'll move it correctly to where it should be. Okay. And you can do the same for Q1, because even in part C, they want us to find the first quartile or the lower quartile of the sold as well. So it's the same thing. You find 1/4 of the sold region and you add it to the shift of the unsold, and that'll put it in the right place. So that's it. Now to actually solve the probability, they want us to find the weight that is more than Q3, right? First, the less than Q3, we found out what it was 0.778. And to get the right hand side, just 1 minus that region, and you should get 0.221. That's it, easy. And now we got to find the value of Q1. So always update your bell curve, guys, yeah? So we just found out that the area greater than Q3 was 0.221. This means that this region between the mean and Q3 must be 0.279, because we know all of this adds up to half, or 0.5. Now, to find Q1, we're going to go ahead and use our result from part B, which is over here. So I'm going to start over here. So we've got the probability that W less than Q1 is 0.3363. Now let's convert that to the standard normal Z form, so minus the mean over standard deviation. Again, still equal to the probability. Now the problem here is that if you look at the normal tables, you'll realize that they always begin with 0.5 onwards, and this is less. Now to get to the bigger version, you would have to 1 minus this probability. And if you want minus, the trick is if you put a minus sign in front of the Z value, you get the mirror value. So that means you can 1 minus this. So literally stick a minus sign, then you 1 minus this probability here to get this value right here. And that's useful because now if you look at the normal table, you'll find out that for the probability roughly equal to 0.6637, you have 2, and you get 2 z values. So you can literally just pick a z value between, but preferably closer to 0.42 because this probability is closer to the first one. Anyway, I chose 0.423, and when you put that in, you just literally make this equal to it. So I forgot to put a minus sign here, but it should be here. And then when you solve it and you make Q1 the subject, you should get about 123 grams. And that's it. That's literally part C. Now finally D. So Betty selects a random sample of 3 potatoes sold by Adam. Okay, again, sold. So we're looking at the white region from the bell curve. Now you can probably see that I've fully updated this bell curve. We got probability between Q1 and the mean. We got between 92 and Q1. So we found this all from the previous question. So you can just subtract a minus and you get every value. Remember, the left side equals a 0.5, so does the right side. Now one important thing to note is that because we're working in terms of sold, we should kind of rescale the normal curve, yeah? So for example, I gave each one a name. I said less than Q1 is L, more than Q3 is M, and between Q1 and Q3 is B. Now, for example, for the probability of L less than Q1, so between that's literally between Q1 and 92, because we're only working on sold, I got 0.2212. And because the whole thing's out of 0.8849, I divided it by the 0.8849. And this gives roughly, I say, a quarter, because it makes sense, it's the lower quarter. And same for more, I got the same value. And between, it'll be between Q1 and Q3, so you got 0.1637 plus 0.2788, and again scale it down, divided by the sold region. So you have these 3. Now to get this correct, because it's a random sample, this means he could have picked these 3 potatoes in any order. So my tip is to always try and figure out the arrangements that it could be. So I did less than, more than, between, L, B, M, and so on. So I put them in a nice, like, simple way to look at it. And then you realize that all the probabilities, if you multiplied all of these 3, for example, you did this probability times M times B, they're all going to give you the same result. So 6 times the same result. So I got it here. And then you just put this in a calculator and done. You literally get your result. And yeah, that's really it, guys. I mean, I hope this this video helped. It was quite intense, question 7. There was a lot of different problems, and I did go through a few times to make sure everything was right. But if you guys spot anything weird or found a better way or faster way, or even if there's any errors on this page, please let me know. Otherwise, have a nice day and I'll see you guys next time. Ciao.